All right, let's dive into Google Cloud data pipelines. There's this one really common mistake in how people set up their storage. A seemingly small thing that could actually be costing your company millions. Seriously, millions of dollars. And the crazy part is, you might not even realize it's happening. So let me just ask you straight up, is your data pipeline secretly leaking money? And I'm being totally serious here, because the way most people set up a pipeline, the default easy way, is often the most expensive one. The good news? The fix isn't about throwing more cash at it. As we're about to see, it's all about smart design. Okay, to really see how this plays out, let's walk through a little case study. Picture this. We're working for a mobile gaming company, right? Our app is super popular and it's generating millions and millions of user events every single day. We're talking level completions, in-app purchases, you name it. And our goal is pretty simple. We just want to analyze all that data to make the game even better. Now, the pipeline itself, it's pretty standard stuff, nothing too fancy. First, you've got the events coming from the app. Then they get sent over to Google Cloud Storage for, ingestion. After that, a tool like Dataflow jumps in to process and transform all that raw data. And finally, everything lands in BigQuery, which is our data warehouse where we do all the analysis. Sound simple, right? Well, the devil, as they say, is in the details. And for us, that detail is step 2. All right, let's jump into design number 1. I call this the naive approach. It's totally the path of least resistance, right? It's the way most people start out because it's just so fast and easy to get up and running. But as you're about to find out, easy, in this case, comes with a pretty hefty price tag. So what does this naive approach actually look like? It's incredibly straightforward. Every single event from every single user gets sent as its own tiny individual file. We're talking maybe just a few kilobytes each. And they all get dumped directly into one giant, massive cloud storage bucket. There's no organization, zero structure, just a relentless stream of tiny little files piling up. So what have you really created here? It's not a data lake, let me tell you that. It's a digital junk drawer. You know what I'm talking about? That drawer in your kitchen where everything just gets thrown in? And trying to find anything, it means you have to rummage through the entire messy collection. That's super inefficient for us. And believe me, it's just as bad, if not worse, for a computer. And this chaos, it has very real, very expensive consequences. See, in Google Cloud, every single time you write a file, that's called a Class A operation, and you get billed for those. So if you have millions of tiny files, that means you have millions of tiny charges that add up fast. Then, when it's time to process the data, your system has to list and open every single one of those files. It is painfully slow. But here's the worst part. When you go to query this data in BigQuery, it has to scan the entire table, the whole junk drawer, every single time, even if you just need one little piece of information. Okay, enough of the bad way. Let's talk about a much, much better way. And here's the cool part. We're not even changing the tools. It's the same pipeline. We're just changing the strategy. By being a little more intentional about how we store our data right from the very beginning, we can build a pipeline that's faster, way smarter, and dramatically cheaper. The whole core of this new strategy is a simple shift in thinking. Instead of millions of tiny files, what we really want are fewer, larger files. So instead of that fire hose of little bitty writes, we're going to batch our events together into bigger, consolidated chunks. Let's say 256 megabytes, or even larger. Just doing that immediately slashes our operational costs and makes the data so much easier for systems like BigQuery to read in parallel. So what's the magic behind all this? It's a technique called Hive-style partitioning. Now, I know that sounds kind of complex, but it's actually super simple. All we're doing is creating a logical folder structure for our data. Think about it. Instead of that one big junk drawer, we're building a nice organized filing cabinet. And we're putting labels on the folders based on how we know we're going to look for the data later on. Things like the date, or maybe a specific customer ID. So here's what that actually looks like in practice. Instead of that one giant bucket, we create folders for each day. And then inside those folders, we can have subfolders for each game or tenant ID. Now check this out. When we need to find data for a specific day or specific tenant, the query engine knows exactly which folder to go look in, and it can just completely ignore everything else. There's a fancy term for this, predicate pushdown, and trust me, it is an absolute game changer. Okay, so this brings us to the moment of truth, the big payoff. Let's put our two designs head to head and see what this little architectural change actually means when we run a simple query in BigQuery. And I gotta tell you, the results, They are absolutely staggering. All right, so let's imagine our analyst wants to look at the event data for just a single tenant from yesterday. Pretty standard request, right? So in our first design, that junk drawer design, how much do you think that costs to run? And what about in our new optimized design? Let's take a look at the numbers. Just look at the scale of this difference. It's wild. The exact same query on the naive design costs $50. 50. Now, with our optimized partition design, 50 cents. That's not a typo. That is a 100 times cost reduction. 100. We're not talking about a small tweak here. This is a fundamental, massive shift in efficiency. Let's break that down a bit more. With the naive design, BigQuery had no choice but to scan the full 10 terabytes of data. That took 3 minutes and, as we saw, cost $50. But with the optimized design, because of our smart partitioning, BigQuery knew it only had to scan the 100 gigabytes that were actually relevant to our query. And the result? The query finished in 5 seconds and cost 50 cents. You get faster answers for a tiny fraction of the price. It's a win-win. So you're probably asking, how can I get these same results? Well, it really all boils down to just a few core principles. Let's go ahead and distill everything we've just talked about into 5 simple, actionable rules for building really efficient data pipelines. All right, let's walk through these. Rule number 1, stop writing tiny files, period. Batch them up into larger objects. Rule 2, partition your data. Build that smart folder structure based on how you actually filter your data most often. Rule 3 is a big one. Choose the right file format. You want to use columnar formats like Avro, Parquet, or ORC. These are perfect for analytics because they let the query engine read only the specific columns of data it needs. So if you just need the player underscore score, it only reads that and ignores everything else. That's a massive speed up. Rule 4, compress your data, but use what's called splittable compression, like Snappy. This lets the system decompress and read just the little parts of a file it needs instead of having to do the whole thing. And finally, rule number 5, which is really the golden rule of all this, think about how you're going to read the data first and let that guide how you design your storage. And that really brings us to the end. This whole principle of aligning your storage layout with your query patterns, it applies way beyond just GCP. This is a fundamental concept for any cloud platform. So I'm going to leave you with this question to think about. What digital junk drawers and hidden costs are lurking in your own cloud architecture? It might just be time to do a little organizing. Thanks for tuning in.